There are four main weather elements that influence fire behavior. Understanding each of these elements independently and how they interact with each other is critical to effective wildfire management. My name is Brett Soderholm, and I am a fire weather meteorologist for the BC Wildfire Service. The four main weather elements in question are relative humidity, wind, precipitation, and temperature. Relative humidity can be thought of as the drying power of the atmosphere. When relative humidity exceeds 40%, fuels and vegetation tend to absorb moisture from the atmosphere, making it that much harder to combust. When the relative humidity drops below about 30%, the opposite occurs, and these fuels dry out by releasing their moisture to the atmosphere. Wind is another key piece. It, in fact, is largely what dictates the movement or growth from fire from one location to the next. Simply put, the direction to which the wind blows is the direction to which the fire grows, assuming flat terrain and uniform fuels. The faster the wind blows, the faster the fire is able to spread. Wind can also cause significant issues for aircraft due to turbulence, which is the rapid rising and falling of air, which may impede operations. And wind at the same time can cause erratic growth on fires at the surface, which may impact the safety of our crews. Precipitation is probably the most intuitive weather element, simply for the fact that if you don't get a lot of it, our fuels have a tendency to dry out. But at the same time, it's not so much the quantity of precipitation that we are concerned about, but rather the duration over which it falls. In a lot of ways, having a lighter amount of precipitation falling over multiple days is far more preferable than having a lot of precipitation falling over a short period of time. Lastly, temperature. Temperature by itself is not conducive to starting wildfires, but it does act in tandem with relative humidity. Assuming the same quantity of moisture in the atmosphere, an increase in temperature tends to decrease the relative humidity, allowing our fuels to dry out, especially if we see above seasonal temperatures for consecutive days in a row.